Okay, so I got the full screen recorder. It should just work as long as I don't hit the escape key, which is a key I do use from time to time. So hopefully it won't notice if I interrupt it. How's that? So first thing we should probably do is to just kind of contextualize it. I'm going to be teaching you JavaScript, but I'm going to be teaching you in a very idiosyncratic way. So you'll have the full capability of JavaScript, but rather than teaching you the whole language, I'm just going to teach you the part of it that is the compatible part with Halo, which will give you the complete functionality. But it's different enough from the usual way in which the JavaScript language is used that it will shift the way that you perceive other people's code, and it'll shift the way that other people perceive your code. So I want to give you essentially just standard disclaimer that while you will be actually in some respects more effective because it's a very organized way to write code, it will also be the case that other people may find it kind of strange because there's a particular idiom that I use, and there's a lot of reasons for that. And I'll describe it if you like, but mostly I just want to focus on the coding part. But like I said, the programming world, if you haven't been part of it, or if you probably have encountered it, has a lot of highly opinionated people. So just making you aware of that. The second thing is that JavaScript's a great language to use because it's basically everywhere. So every browser in the world has it. You may know all this already. Do you know HTML and CSS or any of those kind of things?
I know a little bit of HTML, CSS, and then some Python.
Okay.
When it comes to machine learning. Yeah.
Great. Well, then you may actually be pretty prepared for all this. I'm going to start as if I'm assuming that you know nothing.
Yeah.
But on the other hand, if you know if you know things and I'm taking too long explaining something, tell me and I'll fast forward because it's to your advantage, not to that. And again, part of the reason that I'm doing this is because first I'm excited to teach you, but secondly that I'm hoping that by spending time now with you that you'll save me time later.
Yeah.
That's kind of the trade. So first thing is we want to create a HTML file since we're just going to be doing most of our work in that to start with. So let's just start with sample 1 HTML, and it'll create it as an empty file. I'll fill it in with content from here. So the editor that I'm using is a custom editor, so it's a straight ASCII editor. So in other words, it's just a plain text editor. It doesn't have any special features for italic or highlighting words or any of that kind of stuff. It's specifically just showing you what the raw text is going to be. So the first thing I want to do is construct a HTML file. And as you may remember, HTML files are defined by HTML tags, and a tag is basically in angle brackets. The document's going to want to have a head tag and a body tag. And then usually inside the head tag we're going to want to have a title tag so that the tab will show which it is. So beginning tags basically mark spans. So the HTML tag basically has the starting version and the ending version, and the ending version has that backslash or that
to close it.
The slash to close it. Okay, so you know that. That's good.
I'll do the bracket B, bracket the bold stuff, and then italicized.
Yeah, those are all the things. Yeah, mostly
different functions of brackets to close it. Yeah.
Inside of JavaScript, inside of HTML, I mostly just use the plain tags. I have templates that I use that have more advanced things, but for this kind of lesson, we hardly need any of that stuff because we're going to be working in JavaScript anyway. So all I'm really doing is setting up this context. So inside the body, we want to set up a script tag, which is essentially going to be where JavaScript code will go. So at this point, this is just a straight up bare minimum context to essentially make it possible to run JavaScript. Now there's one amendment that we should make is that there's multiple versions of JavaScript. So this little indentation, the string, which is marked by the double quotes, and the semicolon marks the end of the line. That's it's a special signal to the JavaScript interpreter to tell it to essentially not do old-fashioned things with variables. I can talk about that in a minute, but mostly you're going to want to use this incantation because it will it'll help you to identify errors. Because a lot of time the computer will do what you tell it to, but the real trick is knowing
when there's something wrong on the script,
yeah, knowing when something's wrong, which basically means you want to know when there's a difference between what you think you're telling it and what you're actually telling it. So anything that helps us to identify a difference between our internal expectations as to what's happening versus what's actually happening, that is essential to debugging. So at this particular point, the most important thing to understand about any software language is that essentially it's a sequence like a recipe. So say, for example, I had a recipe for you called Bake a Cake. And so, the first lines might say something like, okay, well, first obtain so many eggs. You want to gather this ingredient and that ingredient. So it'll tell you kind of what you need, right? And there may be steps that are known to you, like, essentially pour so many
water or
so many teaspoons of water or something, cups of flour and so on. So in effect, there's a sequence of steps. First do this, then do that, then do this other thing. And there may even be conditionals, like if the paste is this color,
add more water.
Add more of this. Yeah.
If the flour is too powdery, add more water. If it's too wet, add more powder.
Right.
So you get like the smooth consistency of dough.
And so in effect, you can have conditional statements that essentially change the course of what's done when.
Yeah, like an if then.
Well, you're pretty far ahead. And then rings would be what we would normally think of as a looping structure. So do this until this happens. So you have a sequence of steps that will go back to a prior step. And we'll just keep doing that until some conditional basically throws you out of the loop. So in effect, there's only in computer science there's really only a few things that genuinely matter. Like, so for instance, there's this thing called the Church-Turing thesis, which basically says that once you understand, once you've achieved a certain minimum complexity in a software language, that any software language can represent any program. So our recipe, for example, for baking a cake can be translated into any number of different software languages, and each software language is going to represent that cake in its own way. So, the main thing, like I said, is that there's a sequence of steps that are being performed. Now, unlike in a recipe where we're manipulating physical objects like flour and water and spices and things, in a program we're manipulating variables. Well, we're actually manipulating data that is referred to by variables. It sounds like you know what a variable is already. It's essentially a container in which we can put stuff. Yeah. Okay. So the specific things is to know how to do a variable. So let's see. I'm just going to basically name a variable. So let's test one, I guess. And I can put a value in it, like I can type a string of. So we'll do the classic, absolutely classic starting up program, yeah. Now I technically could put the string. Now a string, by the way, is data that is delimited by single or double quotes. So JavaScript treats single quotes and double quotes as markers of character data, and they treat it more or less equivalently. So I could have used single quotes in this space where I have double quotes showing. Does that make sense?
So they're synonymous.
They're synonymous in JavaScript. Not every language.
Languages sometimes are different.
Yeah, a lot of languages treat this differently, but many languages will use the double quote thing. So I standardize on the double quote. I'll use single quote when I'm writing code into HTML code, typically. So for instance, if I needed to put a string inside of a parameter for a tag, I'd usually use single quotes there. This way, when you're composing HTML code inside of JavaScript code, which happens a fair bit, you can actually intermix the quoting characters in a way that makes sense, but we'll worry about that later. So anyways, this is basically the equivalent of the Hello World program. And to run it, in most file systems, all I have to do is actually just double click on the file. And so you see it opened up the tab. It immediately threw up this box that says hello world, and that's what the alert function does. So if we look at really what's happening here is that the first line sets up a variable called ml_test_1, sets aside a space for the data, and puts a pointer to that data. And then when the alert's called, it's basically taking a parameter. So the parens on either side denote the parameters. So the function itself is actually the word alert. That's a built-in symbol that the Java language interprets when it's running in a browser. Normally we don't like using alert, so I'm going to comment it out. Comment in JavaScript is /. JavaScript does support streaming comments, which some languages will look like that. And so, you know, the /* basically means that I can have comments on more than one line. And I'll just mention that I never use streaming comments except for one exception, which won't become relevant in our conversation. But basically, almost all the time I'm going to be using just this // for comments. But that just letting you know that other comment form exists. The other function that we're going to be using a lot, SOLE, thank you. So the console.log function basically does something very similar to alert, but rather than sending it to the screen, it's going to put it in a special diagnostic area. So if I refresh this page, you don't see any output. But if I go to the browser's version of Developer Tools, there's a console tab in the Developer Tools, and it'll show the message that I used. So the console.log function is basically a function that tells the browser, because the browser's running the JavaScript code. So the browser's basically looking at every line in sequence, and it's just doing whatever that line says. So the console.log function is a function built into the browser that tells the browser to essentially take that string and stick it in this tab.
Okay, instead of the pop-up notification. So
instead of the pop-up notification.
Yeah. Console.
So, given that you know about variables already, I'm just going to skip ahead and start talking about functions. So this class is actually going to go pretty quick because you have a fair bit of experience.
A stronger math background, yeah.
Yeah. So in that sense, we're going to, because a lot of people, I have to explain what a variable is and really spend some time on that. And again, I'm going to show you a specific way of doing things rather than the general way of doing them. So the general way that I'm doing it is essentially specifically oriented towards a particular way of representing code. So like variables, I can define functions. And so a function basically has that form. So this is essentially the simplest possible, actually I'll just call it that, simplest possible function. And actually let's just do that. So the first thing is that I use a very specific naming convention. So one thing that I'll do is I'll first of all I'll put all of my project files in a single directory, and the directory has essentially a name, but it has this _1 at the end of it, and that basically is like a version number. The other thing is that I'm specifically using lowercase with underscores to separate tokens. So if I need a variable is going to consist of an alphanumeric string, which means it's either going to have letters or numbers or an underscore, and it won't begin with a number. It'll only begin either with an underscore or a letter. Now I almost always will prefix the variable name with a symbol type. So for general variables that are defined at the module level, ML is a prefix that I would use. It says module level symbol, and then the _1 means the first version of it, and this particular symbol is the symbol test. JavaScript will allow a handful of other characters to be used as part of a variable name. I would not recommend that you use those. My convention, like I said, is to use both a prefix and a postfix, and to just use underscores and to just use lowercase, because for a lot of reasons having to do with how our psychology works, it's just easier to recognize those kinds of things. But it also has the benefit that if I'm searching through the code, that no symbol ever ends up being a proper substring of any other symbol. I mean, there are a few edge cases where that can happen, but the chances of it are really, really low. And I haven't, in years and years of programming, ever hit one of those cases. So basically, the fn underscore prefix is just a indicator to me to let me know that this symbol is a function. Okay, but you'll notice it has the same assign form. So in other words, there's a left-hand side and a right-hand side, and the function is essentially just like the string up above. It's just going to basically take and treat the function as if it was data, and assign it to the variable name on the left. So in effect, this is a really straightforward way to create a function, is to use this keyword, which is the word function, and then it's going to expect essentially a declaration of what parameters that function takes. The curly braces essentially define the sequence of steps inside of that. Okay.
From this on the math equation or something, right?
Yeah, basically. So
you apply the function to everything inside of the.
Yeah. So in effect, to make a call to this particular function, I can just basically do that. So because so at this particular point, the lines that are above with the var define the function, and then this one right here is how I call it. So if I put the console log thing inside, at this particular point it won't print anything to the screen. But as soon as I uncomment the call, then it'll actually print the console log message to the screen. And just so we can see that, I'm going to adjust the message, and the variable that's defined outside of the function is actually visible to the function call inside of the function. So what it's going to do is it's going to basically define the variable, define the function, call the function, and then basically call the function inside the function. So if I run this, it'll just give you that same message. It's just going to have version 2 now, to just let you know that the code that I edited is the same one that's executing. Sometimes it's helpful to verify that the browser is running the code that you think it is. Occasionally browsers will cache the code, at which point you could be editing the file on a file system, but the browser won't actually show you the new version on the file system. It'll show you the same one that hasn't a cache. So I might increment a version number in some string that's printing to the log so that I can see it. Okay, so this is good so far, and let's see. So we can actually start talking about slightly more advanced concepts. So one of the things that I'm going to start to do is just start implementing some of these conventions. So one of the things is that because I need to keep track of where functions are, I'll usually put a line of dashes in front of it, and then to indicate things that I'm expecting to execute immediately at the interpreter level, because this is the left edge of the screen is effectively being treated as the module level, and I'm going to indent 3 spaces for everything that's part of a function.
Underneath.
Right. It's effectively anything that is, so this line right here is where that symbol is being defined, and all of this stuff is essentially now being loaded into that symbol. So it's because it's in relation to that symbol, I'll indent it 3 spaces. JavaScript doesn't care about the use of white space. In some places it needs it. So for instance, if I took the white space out there, it can't distinguish between the var keyword and the rest of that token. So it needs at least 1 space. But on the equal sign, on the other hand, because the equal sign can't be part of a variable name, it would parse this code.
Oh, the equation equal sign as a space.
Yeah, it'll treat it as if there are spaces on either side. Now, so as a convention, I always put spaces. because it's a lot easier to read that.
Not confusing.
Yeah, basically what I'm showing you is a kind of a mixture of things that are particular to JavaScript and the lessons learned from a really, really long time of working with code. So I'll just naturally do the things that are
easiest to read and comprehend.
Yeah, there's some aspects of this which may seem more cumbersome, at least comparison to a lot of ways that people write software. But on the other hand, the little bit of effort that's saved typing a handful of keystrokes ends up being paid many times over in frustrated debugging. Okay. So, okay. Now, one thing we can do, which you can probably guess, is we could start introducing a particular keyword. So the return keyword basically takes whatever is, so the keyword return needs a space after it unless there's a direct semicolon. So in other words, what the return keyword does is it basically says whatever steps you're performing at this particular point, you're done. And whatever's the tokens that are to the right of the keyword, so in other words, whatever is to the right of the return keyword is going to be the effective value of the entire function call. So say, for example, like you remember that this console log is using this FL test, but I can define variables inside of this function. Hello, San Diego. Okay, so I have this other thing, and I can pass that one. And in fact, you can define variables in multiple places. So the sequence that some languages require you to define all the variables up front. Mm-hmm. And then in JavaScript, for example, you define it whenever, and you can set up assignments to it pretty much at the same time as things, as you've been seeing already, right? So at this particular point, this var example that's inside is the value of this variable is visible. The variable symbol itself is visible to the second log call. But if I were to put this log call, say, there, this would not work.
Because it's outside of that term.
It's outside of the scope. So in other words, variables that are defined inside of functions are accessible only within that function. So the notion of variable scope is to essentially say that both the information that variable refers to and the symbol that is the variable itself, the variable name itself, is only visible in the function where it is defined or any context defined inside of it. Mm-hmm. So basically the module is as if it's a function definition. You can take the whole module as if it's an executing function. Okay. So the test1 variable is visible inside of this function because it's a scope interior to it. Whereas this variable here is not visible in the exterior scope. Mm-hmm. So this all makes sense to you?
Yeah, it has to be nested with the indentation.
Right. Okay. But on the other hand, if I needed to access the value, I could return the value, and now I can treat the function itself, the call of the function, as having a value. Oops, just like that. Okay. So now, even though that first line wouldn't work, the second one would. So does this make sense?
Mm-hmm. Yeah. They have to be nested inside, but if they're underneath,
well,
the variable's run.
So.
But not that one. Yeah, this one won't apply up there. It has to be indented within.
Well, the indentation is not so important. It's the fact that it's within the curly braces. So the curly braces basically define a scope of access. So inside of the function where this function's executing, this variable called example2 exists and has a value. When the return gets called, when the return instruction is being interpreted, what happens is that it's going to signal that I'm only keeping the value referred to by the variable example2 because I designated that this variable is part of what's being returned. It's basically saying that the function as a whole, basically this simple as possible. It's not quite so simple anymore. I should probably change the name. So let's just call it simple at this point. Okay. So simple, basically the two blue lines indicate where it's defined and where it's called. But it's called on the right-hand side of an assign. So every time I have an equals sign, if it's a single equals by itself, it's usually an indication that whatever's on the right-hand side of that equals is going to be treated as a value, as data, that is going to be put into the variable named at the left-hand side. So therefore, I can't have a construct something like 123 equals 456 because you just can't assign a number into a number, right? So the thing that's on the left-hand side, because it's just a pure number, it's not a handle for a place to store data. It's just a number. So I can't basically assert that. It not only does it not work as an equation, it doesn't work as an assignment.
Okay.
So at this point, if I were to run the program, what would you expect to see in the log?
So it's the function that you're calling is var, right? And the function is ML obtained version 1.
So we're on this line here, right? Okay. So what happens when this line basically, when the interpreter, because the interpreter is going to start, it's going to see this, right? It's going to basically say, okay, I'm going to put this hello world version 3 into a variable called ML test. Then it's going to get here and it's going to say, okay, I have a new variable, obtained val, and it's equal to a function. Now the function is going to get called at the time that this line is running. So it's going to go up here. It's going to print, on the console log the contents of this, because the function call is essentially taking the value of this variable because it can see that variable. And it's going to set up a new variable. It's going to put hello San Diego in it. And then it's going to return that variable content. So now when I get back down to this line, it's as if I had put hello San Diego on the right side of this equal sign.
Oh, okay, because you're calling the version 2 not the version 1.
Well,
Hello San Diego versus hello world.
So hello world is in this variable, is in FL test, right? And let's get rid of that comment. So this is going to, in a sense, show in the log.
Hello world pop up on the developer tool window, yeah.
Yep. And then it's going to call this function. It's going to run this line, which is going to call the function. The function is going to become equivalent to hello San Diego because the hello San Diego variable is, in a sense, being handed off to the return. So now the thing, basically this line ends up being equal as if I had written this. So in effect, these two lines end up being the same. So this thing on the right up here, so that the thing on the right of the assign gets the value such that it ends up being equal to this line. Okay? So now the variable ML obtained value is equal to hello San Diego. Okay? And it gets handed off to this console log much the same way as this one does. So therefore it's going to print hello world and then hello San Diego.
Okay.
Does all that make sense to you?
Yeah.
Okay. That's the proof. So
there it is. Yeah, hello world.
right there. Yeah. So look in the console basically. Just because we're not printing anything up into the body of the document. The body of the document would show up here, whereas the console is going to show down here. And there are other things, like you can see the source code for our, like the browser has debugging features built into it. So this is part of the reason why I wanted to show you this, because this is, all of this stuff is available pretty much on most laptop computers. I don't know that your tablet would support all this, But the tablet would certainly run this program. It would show this page, but it might not show you a console because I don't know that it has developed features built into that browser. Safari on iPad may or may not. I just don't know. Oh, you've got Chrome on there.
Yeah.
So see if it's got tools.
Under settings.
I don't know. It'll be under settings. Go back to the menu you were just at. I can't read that from here, so let me just
Bookmarks, tabs.
Keep going. Yeah. Site information. I don't see development settings, so it might not. So let's see. It would be Safari, iPad, Developer Console.
What's called Web Inspector.
Web Inspector.
Open Chrome, click the option settings, about Chrome OS. No, so they don't have it on this.
I don't think they have it. Okay, so your laptop probably will though. Like I said, I think the browser that's running on there just doesn't. It's a version of iOS that just doesn't show it. But anyways, say for example I wanted to run this program line by line. So what I can do is I can mark once I've gone to the sources and I've shown it, I can actually click on the line number. It'll give me that highlighted thing. And when I refresh the page, you'll see that now this device is in a mode called single step mode. So what it'll do is it'll execute these lines one by one, and you can see essentially what it's doing as it goes. So you see it's on line 9 now. So what it did is it just assigned this value to that variable. So if I highlight it, you can see that it has it knows what that variable is, right? Now this next one is going to go straight across because you notice it didn't do anything inside of this because this is all one definition. So this is essentially an assignment that exists on multiple lines. So you see here it says, hey, there's a function definition. Okay. Now it's down here, and it's going to actually pass. It's going to pass into that function. It's going to go inside that function. So the next thing that we see is now the executing line is inside this this console log, right? So if I look at the console, it doesn't have anything yet, but once I run this next line, it does. See, so we've got it. It printed the first line, but before it printed the second one. So now that new variable has a value. I'm going to return that variable. So now at this point, if you look at obtained value, see how over here it has now the value of hello San Diego, right? But we haven't executed the console line yet, so it hasn't printed it. But once I execute this line, now it's in the console. Does all that make sense? Okay.
The order that you execute makes a difference.
The order of execution is critically important. You really want to have in mind the flow of what things happen, and the three concepts that you really want to keep track of are the notion of flow. There's several concepts, but the notion of flow, the notion of the relationship between variables and function calls, right? So essentially, a function is going to be something that transfers your flow of control. It's going to encapsulate a collection of flow statements into a unit, and then you can now move information around in and out of these units with variables, with parameters to functions, and that way there you can kind of encapsulate flows that in a sense make more sense. Like you can take a flow that is, say for example, I have a make cake routine. Then I might have another thing that says make cards, right? And then I might have another function that basically says prepare furniture. And then I can call those functions in succession and make it say have a birthday party. Right? So have a birthday party makes functions that are calls to these individual things, and they just do it. Right? All that is just very straightforward. Yeah. So if I define multiple functions, and I can change what happens inside of this function. So what would be another thing that we could do? We could, well, all right, so let's, at this point you understand the general flow of this pretty well?
Mm-hmm.
Okay. So now I'm going to do something that's kind of tricky. I'm basically going to take one function definition and put it inside.
Do you have water in the kitchen?
Yeah, we have water. Do you need some water?
Mm-hmm.
You want me to just fill that for you?
Do you have hot water or any tea?
Yeah, we do. Okay, let's see.
For order of execution, should we pause the screen recording?
Yeah, I think if